Hello, we're making a video about op amps. So op amps is basically just using application of nodal analysis. So if you're familiar with nodal analysis, this really shouldn't be a big problem here. So the only new things we are adding is knowing what happens on the conditions on the surroundings of the op amp. So we know that the current flowing out of the positive and negative side of the op amps will always be 0. And the current flowing out here is unknown, which we have to account for sometimes. And then we also know that the voltage at each of these nodes, on the plus and the minus out here, will be equal. So from this question, I can immediately identify that this purple node will have a voltage equal to that of V1, which is 3 volts. And this green node will have a voltage of V2, which is 8 volts. Okay, so I have already identified all of the useful nodes in this question. If you're unfamiliar with how to identify all of the nodes in a circuit, please go back to my video on nodal analysis. Hopefully that will clear things up. If not, you're welcome to ask a question and reach out to me, however is convenient for you. Okay, so you can see that there aren't any voltage or current sources in this question that are explicitly noted. So we just start doing our nodal analysis for now. Okay, so let's analyze this pink node, purple node first, because I'm colorblind. Okay, so let's say this is V3, this is V4, and this is just VA. Okay, so analyze node 1, which is the purple one. So we know that there are no current coming in or out of here. So the only current is flowing from V3 to V1 across R1. So our equation would just be V3 minus V1 over R1, which is 800 equals to 0. And V1 is just equals to 3. So you can just conclude that V3 equals to 3 here. Okay, let's look at node 2. In node 2, we have V4 minus V2, which is 8, over R5, which is 4,000 equals to 0. So we have V4 equals to 8. Okay, so it gets a little bit more complicated with node 3 and node 4, but you actually don't have to solve for them. For the sake of completion, I'm gonna write them later. So yeah, I'm just gonna analyze node 8 first. So there are 4 resistors. I'm just gonna randomly define the direction of flow here. So this would be the current coming in equals to the current coming out. The current coming in, we have V3 minus VA, so 3 minus VA over R4, which is 3200, plus here V4 minus VA over R2, and then minus VA over R6. My cat is being loud, I'm so sorry. And then here over R3 equals to 0. And actually we can already solve this equation because this is just like with one dependent variable. So yeah, the setup of this question isn't really tricky. So here's the answer that I got in case anyone wants to check that. Anyways, we can analyze V3 and V4, but like be really careful not to ignore the current coming out here. So if this is actually required to be analyzed, which it will be in some cases, you have to account for the current coming out of the op amp. And most of the time you have to define a new variable just to account for that. So here, let's account this as I1 and let's account this as I2. Okay, so for node 3, we have I1 coming in minus 2 nodes coming out. So we have V3 minus V1 over R1 800. And this is just 0 because V3 equals to V1. And then minus V3 minus VA. So 3 minus VA over R4 equals to 0. So after solving for VA, we can just solve for I1 if we want. The same thing for I2, so I'm not going to do that again. Okay, hopefully this is clear enough. If not, just let me know. I'm really happy to answer any questions you might have. Anyways, this is my last video before quiz 2. Hope this helped someone.